All right, this is question number 29 for the TNReady practice test. I'm trying to make this so it'll fit nicely in there for you. There you go. For geometry. So the quadrilateral LMNO has coordinates of 5, 6, 9, 8, 11, 12, and 7, 10. So let's sort of sketch that out just a little bit. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and up to 12. Now you may not need to draw it all out, but I like to be able to visualize it, even if it's not very well drawn. So point L is at 5, 6, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6. That's point L. M is at 9 and 8, so this is 5, 6, 7, 8, 9. I'm at 6, 7, 8. Obviously it helps if you can draw scale better than me. N is at 11, which I think this is 11, so this is should be over here just a little bit. $11 and all the way up to 12, so up here, that's where N is located, and O is at 7 and 10. So while it's not extremely well drawn, it gives me some hope for the future about how far apart these things are. So now I want to know, how can the quadrilateral be classified? So what's nice for me to know is to be able to figure out the distance between parts so I can figure out how long these are. I'm always one who tends to do Pythagorean theorem in this case. So to go from M to N, I want to look at, okay, how far apart are the x values? That will give me my, so if I do this way, and I'll speed it up after this, if I go from the x value of 9 to the x value of 11, that's 2. If I go from the y value of 8 up to 12, that gives me 4. And now I'm ready to do this. (16 plus 4) C is the square root of 20. So for this distance here, square root of 20. Also, I might notice that MN, so if I was going to do slopes over here, just to take a note, because they'll ask me about certain things, it goes up 12 minus 8, so 4, and it goes over 9 to 11, so that's 2. So it has a slope of 2. Let's do ON. The slope goes from 10 to 12, so it's up 2, and it goes from 7 to 11. That's 4, so it's 1/2. OL, L is the first one, that's when you start with. It goes from 6 to 10, so that's 4, and it goes from 5 to 7, so that's 2. So MN and OL have parallel slopes. LM, its rise would be 6 to 8, that would be 2, and its run, 6 to 8, and its run would be 5 to 9, which is 4, equals 1/2. So I know that opposite sides have parallel slopes. So I know at least it's a parallelogram. But now I need to go on and see what else I can learn about the side lengths. So for, this is the length of MN. For OL, the nice thing about having these slope pieces is they tell me what the sides are going to be. So for OL, to go up is 4 and to go over is 2. So 2 squared plus 4 squared equals something we're very used to at this point, which is 20. So for side lengths, MN is equal to the square root of 20, and OL is also the square root of 20. For ON, again, having these pieces is nice. It gives me from O to N on the x-axis, it would be 4. I guess I should use equal here because I don't really want to do that. I'll just do that. Plus, and then to go from here to here would be my y's, and that would be 10 to 2. So this again, ON squared is equal to 20. So ON is equal to the square root of 20. So far we have ON is the square root of 20. And then all we need to look at is LM. Squared would be, if I was going to make this triangle here, to go from L to M, I'm looking at 9 minus 5, which is 4. Again, 2 here. So LM is also equal to the square root of 20. So that means we have a quadrilateral that has parallel sides. We have all sides are the same, so that makes it at least a rhombus. Now, is it rhombus but not a square? Or is it rhombus and a square? Well, a square has 90-degree angles, and these are certainly not 90-degree angles, so that is out. So our answer to number 29 is it is a rhombus but not a square. It's not a rectangle either, because again, you still have to have those right angles in there for it to be a rectangle. Also, a rectangle has opposite sides congruent, but not necessarily the all sides being congruent. So your answer to number 29 is B. A little difficult, but if you can draw it out a little bit, I think it makes it much easier. Probably if you're going to make this type of analysis, it's better to go ahead and do the slope, because if you want to use the distance formula, you'll have the pieces that you need to just convert it into Pythagorean theorem, as opposed to just always, let me do the full distance formula, the square root of y is 2 minus y is 1 squared, that whole thing. Instead, if you have all these parts, you can use this as your A and this is your B. Work them out, calculations will go a lot smoother. So if you can find the slope first, then worry about the distance, I think you'll find that to be an optimum situation.